Okay, so today we're going to be going over the indefinite integral. If you're watching this video, that probably means you just now learned about integrals. You've been doing derivatives this whole time now. You switched to integrals, which are pretty much just the opposite of derivatives. So let's just go ahead and jump in. That's really the best way to get a hold on these things. So we have an x times 1 plus x cubed in the parentheses. So you should always distribute when you can. So we're going to distribute that x in, x plus x to the 4 dx. Let me just rewrite this x to the 4th real quick. Okay. And so now whenever you have a plus, you can actually handle it as two different integrals. Like they're totally separate. You could even write it like this if you wanted to. Integral of x dx plus x fourth dx. These two things are exactly the same actually. But we don't have to do this because this is like a longer notation. This is just a way to help you visualize what's actually happening here. But we can take the derivatives of these two polynomials separately, or the integral. We can integrate them separately. So first we'll integrate x, and so hopefully you remember how to integrate. If not, we'll go over it pretty briefly. So when you took a derivative, for example, you would take the 2 and you would multiply it. It would become the coefficient. And then it would be whatever your exponent was minus 1 for a derivative. But for integral, it's actually the opposite. You're going to add 1 to the exponent. And so this becomes 3, and then you divide by that new exponent. Okay? So the integral of x would be, well, we have a 1 in the exponent right now. 1 plus 1 is 2. And then you divide by that number, 2. Now for taking the derivative of x to the 4th. 4 plus 1 is 5. So now we have a 5 in the power. And we just divide by 5. And if it's an indefinite integral, indefinite means there's no limits. Like definite integrals will have limits, like sometimes it's like -1 to 1 or whatever. That's a definite integral, and then you'll plug the numbers into the x. But if we're doing indefinite integrals that don't have limits, you have to always put plus c. It's just the constant of integration. So this is your answer here. F of x equals. And if you're not sure, what's nice about integration is if you're not sure if that's the correct answer, you can just take the derivative of it, and you should get back what you started with, either this or this. So we can just do that really quickly. Derivative of x squared over 2. Well, we multiply the coefficient by 2, and then 2 minus 1 is just x over 2. So these 2's cancel, and you're left with just an x, which is good. That's what we want. How about x to the 5 over 5? Well, we multiply the coefficient by 5, and this becomes a 4. So that's good. We have an x4, and then the 5's cancel. So you ended up with what you started with. So that's how you know you're doing these correctly. Next problem. This one's a little bit more complicated, and this is a pretty nice trick to deal with fractions. Okay. So what we can do for this is, there's no like quotient rule for integration like that, how there is for derivation. But if there's one polynomial on the bottom, see how there's just one, it's not x to the 4th plus anything or minus anything, it's just one digit at the bottom by itself. Well, when that happens, we can rewrite our problem. It's essentially a type of distribution where you're essentially distributing the denominator. 2x squared over x. And I accidentally put in a positive there. Minus, and then dx. So now we get 3 terms instead of one long fraction. And then usually with these types of problems, you can always reduce this. So x5 over x4, when you divide exponents, you just add or subtract them. And so x5 minus x4 is x. Here, x squared minus x to the fourth, well, it's going to give you a negative 2. And then here, since it's a 1 on top, you can just bring this 4 to the numerator and make it negative. So we haven't done any integration yet. All we've done is algebraic operations. This is all algebra here. Distributing your denominator to each component of the numerator, and then manipulating the fractions. That's why it's really important to have strong algebra when you're doing calculus, because if you have weak algebra, you're not going to be able to succeed in calculus. Okay, now we'll actually take our integrals. So the integral of x, 1 plus 1, and then you divide by the new exponent. Over here, negative 2 plus 1 is negative 1, and you divide by negative 1. Over here, negative 4 plus 1 will be negative 3. Divide by negative 3. And that's going to be our, so these can become positive, and then always remember the plus c, the constant of integration. And this is our final answer. We can simplify it a little bit to make it look nicer. So we'll just go ahead and do that. F of x squared over 2. And then so we can move this x to the numerator. This subtract this minus out here. Minus 2 over x. And then over here we can bring this x to the negative 3 to the denominator. And since there's nothing else on top, it's just a 1 over 3x cubed plus c. And that is our final answer. Alright, last problem. I decided to use a t as the variable instead of x, just because it's good to see other variables, and many times as your education advances, you're going to see other variables, so it's important to get comfortable with them. And so since we have this 2t squared in the denominator, we can always move that up to the numerator just to make our integration easier. E to the t dt. So let's go ahead and integrate. This one should be pretty straightforward. Negative 2 plus 1 is going to be negative 1. Then you divide by negative 1. Now, the derivative of e of t was just the same thing if you remember from your derivatives. E to the x does not have a derivative, it stays the same, which means when you integrate it, it stays the same. So e to the t stays the same, and always remember your constant of integration. Now let's go ahead and rewrite this so that it's a little bit nicer. F of x equals, so it's going to be negative. You actually pull the negative out in front of the entire thing. 2 over t plus, this is now plus, we pull the negative out of this and this. And then minus c now. And that is our final answer.